Hey guys, this is Algebra for Faith. This is the lesson for April 30th, and today we are going to be factoring completely in 10.5. And before we get into our lesson opener, I just wanted you to, if you're with me on page 425 where we start 10.5, you can just see that they're talking existentially. No, that's not right. Existentially, where basically they're talking about how for your purposes, for high school algebra, or anyway, for Algebra 1, we are only factoring over the set of integers. We're not going into imaginary numbers like these radicals and things there. So basically, if you're reading that first section, you're like, what? You don't have to worry about it. It's basically saying, just relax. We're not factoring imaginary numbers. We're not factoring with radicals here. We're only over that set of integers. We can't factor with radicals because a radical is not an integer at this point. So we are going to go ahead and start looking over your lesson, and I want to talk about what we've done so far, because basically 10.5 is the culmination of 10.1 through 10.4, and we're just adding one little thing with 10.5, and then you've got a quiz that has come to you on 10.5. You have a test that's coming on chapter 10. That's what you're going to be doing on Monday and Tuesday. Tomorrow, May 1st, I will be doing some review for your test. And then, of course, you won't have an interview. You won't have a video for May 4th or May 5th because I'm giving you those 2 days to try to finish up your test. If you're stuck on your test, please, please, please send me a text, something, and I'll try to get you started on it. Also, for those of you who think you're pretty savvy on this stuff, I do know that some of you are probably, it was really obvious on that last test for chapter 9. Some of you were able to, not get anything on the first page, not get anything on the second page, or on the third page, but magically got everything right on that second page. You all did not become geniuses overnight. I'm very much aware that most of you might be using photomath for those. That's what it became really obvious for, and the other ones photomath didn't work on. Well, that's just how tests and quizzes are. Normally, some of it you can get with a certain application, but the others you can't. So it kind of all balances out. You've got to know, that's just how life is. Sometimes there's problems, a calculator, an app, nothing's going to help you. You just have to settle down and go ahead and work on it. And that's one reason why we're doing videos still on this. Hopefully my phone will not, it's about to drop off. So let's look at your lesson opener, and then we're going to talk about it just a little bit. So this first lesson opener is going all the way back to 10.1, and 10.1 is where we're really concentrating on common monomials. And when you're factoring trinomials and polynomials, that's your first clue, is factor out the common monomial. So what's common between the 6x and the 12? Those are even numbers, so I need to factor out the 2 from each of that. So 6 divided by 2 would be 3x. And then, of course, actually, we need to factor out a little more. Yeah, that's not a common monomial. We need to go a little bit bigger. That was prime. So what would be a little bit bigger? How about the 6? Yeah, factor out the 6. Divide 6x by 6 is just going to be x. Divide the 12 by 6, and it's going to become 2. So that's the common monomial between two of those. Yes, the 2 would have worked, but you'd very quickly figured out, wait a second, I'm going to have to take it down one more time. And that's what you're trying to do. You're factoring it down to primes, not leaving it into to where there's something else in here that can be factored out. Let's look at this next one. This is one that's been factored for you. Remember yesterday we kept saying we're looking for common binomials? I feel like in chapter, or this section, 10.5, and on your quiz, and on your test, they're throwing a few problems up there for you that looks just like this. And you're like, what am I supposed to do? It's already done for you. Basically, you have 2 common binomials. Bring that common binomial down. there's another binomial here, the x plus 7. So on your quiz, on your test, if you have a problem that you can see that inside the parentheses it's common, chances are it's already been done for you. So you just need to recognize, ooh, common binomial, bring that down, and then recognize what's outside the parentheses is another one. So let's go down to, this one kind of comes from 10.2, and that was our basic pattern that we are trying to factor. So what am I doing with 10.2? I'm looking at this number. I'm looking at, which that would be technically C. What are factors of C that I could add together and get up this -1 in the middle. So what are factors of C, or what is factors of that 12 that I could add together and get a -1 right there in the middle? Well, that one is probably kind of easy for you. So you're basically looking for two factors of 12 that are right beside each other in the number line. That would be so x is going to factor as x, that would be x squared. But what would be two factors of 12 where they're right beside each other in the number line? Well, that would be 4 and 3. And then before you put your sign numbers up here, you got to make sure that the larger factor is going to be this sign. So 4 needs to be negative, and 3 needs to be positive. The next one comes from 10.4. 10.4 is what we did yesterday. It was special patterns. It's one that we should recognize. So 10.4, when I look at it, that's called, perfect, right? Sorry, not a perfect square. That's going to be a difference of squares. Down here is going to be perfect of squares. This is going to be a difference of squares. It's going to be difference because I end up with that negative right there in the middle. So what was my two binomials I was squaring together? With nothing else, you got the x. Guys, if nothing else, if you put the x down, you've done part of it, and I can give you partial credit on a quiz or a test. Don't give up. Don't leave stuff blank. Then what would be, since it's a difference, one is going to have to be positive, one's going to have to be negative. What's the square of 81? That's a perfect square that you probably learned in 5th, 6th, 7th grade. That would be a 9. So that's a pattern that we call difference of squares. So when you have something that looks like this, you know, okay, I know what my binomials is going to look like. Now, down here, this could be a perfect square. You could go all the way back and you could say, okay, it could look like 10.2 as well. It could. And so what am I trying to do? You could say to yourself using 10.2 strategy, I'm trying to find factors of 1 or factors of this up here, the factor of this one and this one, which would be 1, that would end up becoming a positive 2. But what you could also say, that's a perfect square, this is a perfect square. Technically, it would be 2 times 1, 2 times A and B, remember? 2 times A and B in order to get that in the middle. So this is actually a perfect square. So a perfect square is going to mean these two, and you could put it, that's basically going to be x plus 1 squared. So that would end up being a perfect square, where you would end up having, okay, that's going to be that 2, that will be doubled in the middle. My C would be doubled in the middle, or my AB would be however you want to put it down. And that would be, so this one was a perfect square. So today's lesson, we are going to do some Bible verses. Where did that come out? We are going to do some homework, but I do want to very slowly work out through the first 3 examples. You have them in your book, so that should help you as well. But I want to go through the first 3 so you can kind of see exactly what we're doing. Then right before we go into the homework, we're going to look over what those strategies are. And to be honest, 10.5 That's those strategies that they give you on page 426. That's what you need for every single section, quiz, test test question, is those strategies that they're giving you on page 426. So let's go to example 1. Let's scroll down the board. This is going to be distracting if I see it, so I'm going to get rid of this. We might write out our strategies over here in a second. So example 1 is on page 425 in your book. I'm going to move it I don't know how to move that. So let's look at this one. Example 1 basically is 5ax to the 5th power minus 5axy to the 4th power. So we go back to the strategy that we used in 10.1. It's the first strategy whenever we factor, and that's to say, I need to factor out common monomial. There is a common monomial in those, and we can look at it. Over here I have a 5a. Over here I have a 5a. Let's go ahead and factor out the 5a. Then inside I still have x5 and I have xy4, right? So which means we didn't factor out everything. We also had a common, we have a common x, 5ax. So let's factor out that. So inside I still have x to the 4th power. Is that right? We've got x to the 4th power. And then also the 5ax is gone. We still have y to the 4th power. Now when you look at that, that might start hitting and make you think, wait a second, that looks like one of those common patterns I had yesterday. And if it does, you were exactly right. It's a common pattern we used in, that I just erased, we used right over here. This is a difference of squares. So that is going to be the difference of squares. So think of how that would end up. Still have to keep bringing down that common monomial because I need it. That would be x squared plus y squared. But since it's a difference of squares, I've also got to have x squared minus y squared. So that's my difference of squares. And then look at this again. You could almost say, wait a second, right? One of those is no longer a different square. One of those I still need to be able to break down. And it's this one, because that's technically a perfect square, or another, it's another difference of squares. This one right here is. So that was a difference of squares. We broke it down into 2. Another difference of squares. So I have to bring down everything that I can't break down, which is now this and this. And this is going to break down into that regular pattern of difference of squares that we learned yesterday. And technically we learned it the day before as well. Now it's factored completely. Now we've gone down step by step by step, and it's factored completely. You have to make sure you include everything. We started out by factoring out the common monomial. Then we discovered, okay, that is that's the difference of squares. We broke that down. This is another difference of squares. We broke that down. Now it's factored completely. Something like this is not going to factor down. Something like that, you've got one that looks really similar to it on your test. We'll go over it a little more in review, but you can't, that's not a difference of squares. You can't factor that down. It's going to be prime. So let's move over to your next example. I'm going to get rid of this one so you won't get distracted, hopefully. I'm the one that gets distracted, not you guys. So wait a sec. Did I say today was May 1st? Now, today's April 30th. I think I said that. May 1st is when we're doing review. But who knows? All right. So let's look at our next example. We have x to the 4th, 9x. I left out something. 8. Sorry, I got distracted there. So x to the 4th power, 9x squared, plus 8. We can, our first strategy is common monomial. There ain't one. Sorry, grammar. There is not one through there. No common monomial. We can look for a special pattern. No special pattern. There's no difference of squares. There's no perfect square trinomial there either, like we studied yesterday. So what am I going to start doing? Well, since I don't have one right here, since I don't have that, I have nothing with that, that is going back to technically 10.2. And where I'm starting to say, all right, what are factors of 8 that if I put them together, I would end up with a -9 in the middle. So factors of 8 that if I added those two factors together, the sum will become a -9. And that's probably where you're going to start to say, I think I can kind of figure that out. So this is going to be x to the 4th. So think of what happened to those two. So I'm going to have an x squared. Then I'm going to have, what would be factors of 8? Where I put them together, I ended up with that -9. I had two factors of 8. That would be 8 times 1. So you can do this however, put it down. I may have done this exactly opposite from what it was in, yeah, I did. I did it exactly opposite from what's in the example, that's fine. Well, this one is factored all the way down. You can kind of see all the way. Like this one is not a difference of squares. This one is now a difference of squares. So I can break that one down a little further. It's one of my special patterns I used in 10.4. So this x squared minus 8 will just stay there. This one will break down into two binomials. One will be x plus 1, and the other one will be x minus 1, because that is a difference of squares. So that's one example. Going to example 3, I will let the other two examples that are on the next page, it's where basically you're doing something similar, but you're doing it with letters. But after example 3, we're going to go over your strategies. Then we're going to start some of your homework. So they tell you in a little sentence right before we get to example 3 that in some expressions you can factor common factors not from the entire thing, but from little groups. So this is when you get to where there's not a common monomial all the way through it, but if I grouped it together, this little group has something common, and this little group over here has something common. This is when you start grouping. So in some expressions, you can factor common factors from several groupings of the term, and then to leave a common binomial. So this one doesn't fit a pattern. This one does not have there's not a common monomial all the way through it. But what I can see is this first group has something common in it, and it's x. This second group, the numbers have something common. I could factor out 5 from those two numbers. So this one here has something common, and it's x. These two have something common, and that they're factors of 5. I could go ahead and divide both of those numbers by a 5. And then we can see what we got. If we don't have anything common, we'll leave it like that. If we do have something common, we'll factor that down further. So first of all, I'll take the x out. So now I've got 2y minus 7. Now I'm going to factor out the 5. Divide the 10 by 5, I have 2y. Divide the 35 by 5, and I have 7. Then I look. Common binomial. I have a common binomial. So I'm going to bring down that one common binomial. What's my other binomial? This right here. X plus 5. And of course, to check yourself, you could go back and use that full method to see if you're going to end up with something that's going to look like this up here. That's what they always show you, that if you factor those down, that's the complete, factorization is going all the way down here. So let's look at our strategies. the strategies that we've got over here on page 426. You can look over example 4 and example 5 for your own benefit, or if you have more stuff. I'm just going to tell you, your quiz for chapter 5, or for 10.5, is practically everything that you've done in this chapter, or it's practically every example. We're going to do some in your homework that looks really, really similar to one that's in your quiz. None of them, nothing on your quiz tomorrow is prime. Nothing. So if you think nothing's factoring out, it's just prime, that is wrong. Do not put prime down on your quiz. Remember, on your test, only one is prime. And I kind of told you in the lesson opener what one would look like, but tomorrow's review, I'll tell you exactly what that prime one's going to look at. It's just for you to recognize it from a special product or for a special pattern. So let's go over your strategies as we go over it. So I'm going to I'm not. Let's just concentrate on strategies first. So I'm looking over this table, and I've put quiz and test right here. Your first strategy is from 10.1. Factor out that common monomial. Is there a common monomial? Is there an x all the way through it? Can I divide out 2? Can I divide every number by 5 or every number by 3? Then is where you've got basically 5 different strategies you could use. Do I recognize it from 10.4 as being a difference of squares? That's probably the easiest one to pick up, and that's what you want to look at. If it's still a trinomial, is it a perfect square binomial? And they've given you those two, that one reference. That's 10.4, what we did yesterday. Is that trinomial a perfect square binomial? Does it end up becoming a square plus or minus 2ab plus b square? So that's something to pick up. If not, then I look at the very first term. Does x square, the very first term, have something with it? And if it does, then I have to use one strategy. That's from 10.2. If that very first term, if that x square has something with it, then I look at C. That comes from 10.3. That was the British factoring method. That's basically me multiplying A and C together and then seeing what factors of A and C together would give me that middle term. So the final one that we learned today, the only thing new that you learned today was that last thing we did with example 3, which is grouping. So 10.5 is, all right, the polynomial does not give me difference of squares. It doesn't give me a perfect square trinomial. It doesn't give me a trinomial from 10.2. It doesn't give me a 10.3 trinomial. If it has more than 3, it's a polynomial. So then that's when I stop and I say, okay, can I group some of these together and then start factoring out something common, some type of common monomial from that, and see if I can factor it down more. And as you can see, sometimes you'd factor down and you still had a perfect square, so you had to factor down more. And that's your strategy, is to factor and factor until you cannot factor anymore. So I'm going to go all the way over this side, so hopefully I don't have to keep erasing and keep erasing. My cord is hung up. I don't like to look at that thingy. So there's factoring. Yeah, factoring completely. Let's go to number 9 is where I'm looking at. Because if you look at the first section, it's pretty common factors that you're doing. What they're really doing with that first section, every single one of them, they're going common monomial. Factor out the common monomial. That's what they're looking for. And then after you get that, you can try to see, is it a perfect square? Do I need to do difference of squares, or whatever the case may be. Now, if we start with 9, that's your new thing today. And they're telling you, you're going to have to factor these little things with grouping. So number 9 looks like this. And the reason why I chose number 9 is because on your test, on your quiz, you'll have something that says factor by grouping, and they'll give you something like this, and you start freaking out. But what's there already? This one's done for you. This one just has one more step, guys. And that step is basically for you to recognize, I have a common binomial already. I already have that common binomial, so I'm going to drop that down and then put my other binomial with it, which will be this. And then I'm done. That's one reason why I wanted to do that one. It's on your test. It's on your quiz. It's just, I feel like they think, ooh, I can trick them if I do this. Now I'm going to go to 11 because on your test and your quiz, you do have some that's just purely literal equations. Remember, literal equation just means it's an equation that, this one isn't an equation, it's an expression that just has letters, so it's not that big of a deal. They want you to just understand, okay, I still need to do the same strategies. And so I thought, let's do this one so you just won't freak out over this one since it's all letters. All right, so I'm grouping. I'm having to group this one. This one they've actually already grouped for you. You know, so yeah. And like you got one on your quiz, you got one on your test where it's just pure letters. Well, what's common from this first binomial? A. So I'm going to go ahead and take that out. So now I have t minus w. What is common between the second binomial? Oh, it's b. So I'm going to go ahead and factor out b. Then I should go to my next strategy. Oh, you know what? I already have a common binomial. T minus w, they're both common. So I'm going to bring that down one time. And then what's my other binomial? A plus b. So that's, remember, common binomials. Looking for a common monomial, then you're trying to get it down to a common binomial. And then you're kind of done. So let's look over now on page 427. And we're going to do 3 more. One of them is really weird, but I wanted to do it with you because your last question on the quiz is really, really weird. So let's do 19. So 19 looks like this. I'm not sure if you can see me or not. I'm going to move her down just a little. 19 looks like 18x squared minus 3x minus 36. And then let's go all the way back to our strategies that we did. So our strategies basically was factor out common monomials. Well, look at each of these numbers. There should be something that stands out to you. Each of those numbers is divisible by something. That 3 is even divisible by it. All of these numbers are divisible by 3. So I need to factor that out first. So I'm going to factor out the 3. That's going to become 6x squared. This will simply become negative x. And this very last one is going to end up becoming a 12. Now I look here in the middle. And when I look here in the middle, you know, I can start thinking about what my strategies are. That's not a perfect square. Right? So it's not a perfect square trinomial. Yay, right? It's one of those trinomials that there's something with it. So that tells me I need to go to what factoring method? The British factoring method. And that's basically me taking 6 times 12. So if I think about it, 6 times 12, and then I'm going to try to figure out what are factors of 6 times 12 that would end up becoming, right there in the middle, a negative 1, right? The other, because we can't factor out, there's, you know, yes, we can't factor out another common monomial from that. If we did, that means we didn't go big enough. So that's the only thing I can do. So what is 6 times 12, and what are factors of those that I can break down and make them become I can make them become this right here in the middle, the middle part. Okay, I'm just I don't even know what I'm trying to say anymore at this point. So, so rewrite those middle terms of A times C. Okay, now my screensaver is coming back. I don't know if my screensaver like goes out for you guys or not. So rewrite the middle term using factors of A and C whose sum is B as coefficients, and then factor by grouping. So this is from 10.3 if you want to look at it. So A times, so I'm just going to say A times C. 6, I don't even have it with me. And I so if you're wondering what I'm doing, my brain has just shut down. So I am looking at this really quickly. That's what I thought, but my brain is still really quickly shutting down. So A times C, what is factors of 72 that would end up being B? And B is a negative 1. So what are factors of those that would become that? Remember, now we're going to group it. We're not going to freak out here. We are going to end up grouping these. So factors of 7 and 2 that would end up becoming, or 72, that would end up becoming a negative 9 would more than likely be, are you with me? Would more than likely be the 7 and the 9. Okay, right? So 8, let's see, just looking, divided by, yeah, 8 and 9. Now, yes, it's going to break down even further, but I'm just trying to get you to see what would happen. So let's do this, bring that down, bring down the common one. We still have 6x squared. So one of these is going to be, I'm trying to just check and see how we're doing this. One of these is going to be 8, because the bigger one is going to have to end up becoming, and then, oh, wait. Forgot what I was doing. And then the other one is going to have to be 9x, and then we're going to have that. And now I'm going to try to judge and see, okay, have I put that where it needs to be? And now, when I get to this point, is where I'm going to try to group it together and see, can I break this down even further? That's what we did all the way back over in 10.3. So it might be one of those things where you might want to break it down and say, okay, what am I doing here? Can I break down these two numbers? Can I group this? Can I group that? Can I factor something out? And so if we start factoring things out of this one, 3 is still going to be over here. What could I factor out with that? Well, obviously the x is going to factor out, right? But what else is going to factor out of these two? I would factor out the 2 from that. So now I've got 2x. This is going to become inside here. So I have 2x. Right here is going to become 3x, right? And then I'm factoring out the 2x there, so that's going to be a plus 4. Then I'm going to go on this side, and I'm going to say, okay, this is my big brackety brackets. This is probably one of the more difficult problems you get. I can factor out a 3, right? Probably the only thing I could really factor out there is going to be that 3, that negative 3. So this is going to become factoring out the 3, that will become a 3x. Factor out the 3, that's going to become a positive 4. Now, hallelujah, I have a common binomial, right? 3x plus 4. 3x plus 4. I have a common binomial. I can break this down even more. I have to bring down this one. I'm going to only bring down the 3x plus 4 one time. What's my other binomial? My other binomial is the 2x minus 3. Remember doing that in 10.3? I was even foggy on it. So it might be that you have to go all the way to 10.3 just to go over those a little bit. Now I'm going to come all the way back over here, and we're going to do another one that I chose that's kind of similar to what's on your quiz. And that is 29. I think is what I chose, which means I need to erase some of this. And then we're going to do one really weird one. So far, no word problems on any of these. There might be one on your test, but I'm covering that tomorrow in review. So looking at 29. 29 looks like this. We have y cubed minus 3y squared minus 4y, and then we have plus 12. Well, right off the bat, when we start doing this, you can see this is not a trinomial. So I need to start considering what's my strategies. So it's not a trinomial. That tells me that's probably not a perfect square. I'll look through all of them. Nothing is common. There's not a common monomial there. So what was my strategy? It's the strategy you learned in today's chapter. The strategy, they said, is group it and then see if you can get some common factors from that. So we're going to group the y squared, the y cubed minus 3y squared, and we're going to group the 4y plus 12. Is there something common in those groups? Well, in this group, the y is common, but not just y. If you noticed it, it would be y squared is common. I know that's kind of weird, but y squared is common. So if we're inside, you end up with y minus 3, right? And then when we're over here, we've got 4 is common. So I'm going to take out the 4, and I end up with y, that's going to be a negative 4, minus 3. Well, hallelujah, right? We have a common binomial. So I'm going to bring down the y minus 3 one time, and then got the y squared minus 4. Hallelujah, done, right? No, because you've got something right here, and you should recognize that as the difference of squares, right? Remember, this would be, but it's a very easy pattern. This needs to become the difference of squares. So the difference of squares, I'm going to take the square of y. It's going to just be y. I'm going to take the square of 4, and it's going to be a 2. And then one of them is going to have to be a plus because it's the difference of squares. One of them is going to have to be a negative, and then I'll bring this one down too. Now, this is completely factored all the way through. You're not through factoring until you have factored all the way down to this. So if you end up with a y squared and a number that can be squared, that's where you might want to say, I might need to factor that a little bit more. Now I want to do 37, because 37 looks really weird, and 37 looks, to me, somewhat similar to what you're going to be doing on your very last problem on your quiz for 10.5. It's not exactly right. I mean, it's not exactly the same, but it is somewhat similar to it. I cannot say the word similar or similarly. So 37 looks like, hold on, let's flip my page here and see if I've got it written out. And so is that right? We have x squared, x squared, and then we have a plus 2xy, and then we have y squared, and then hanging out here, we have a negative 9. This one is where you want to group, but when you start looking at it, the first thing you look at is, all right, do I have a common monomial? That's my first strategy. Do I have a common monomial? I'm going through this step by step. You can look through each step. Don't have a common monomial. Nothing's common. My next step is I start considering those polynomials and going over certain strategies for those. So is it a difference of squares through there? No. Do I have a perfect square trinomial? Well, it's not a trinomial, so technically you could go ahead and just do away with that whole second section. It's not difference of squares. It's a binomial, not a binomial, not a trinomial. You have to go all the way to your last strategy that was in today's lesson, which is grouping. This grouping is going to be weird though, guys. If you say, wait a second, yeah, The only thing that you've got common is this trinomial that's right here. So go ahead and use your strategy and let's factor out what is common through there. And what is common through that trinomial is I put these together and now I see a pattern. There's not a common monomial, but in this trinomial, there's a pattern that should ring out to me. That is a perfect square trinomial. You can go all the way back to your strategy over here on page 426, and it shows you that is a perfect square trinomial. How do I write that out? Then I'm going to write that out as basically, know exactly what this is. That is going to be, I have to flip again. X, and you could write it down, x plus y squared, right? That's my perfect square trinomial. So that's what it is. Then I might notice something over here, because technically I could break that down just a little bit further to make it all squared. 9 is a perfect square as well. So that's why this one, your next one's a little weird. 9 is also a perfect square. What's the square root of 9? Technically, it would be 3. And then what I'm going to do is I'm going to write this out into 2 trinomials because I'm not quite factored all the way. So what am I going to do? This, I'm going to, or you could say technically this is another difference of squares. I've got x plus y, and then one of these I'm going to have it down as a -3. Then I've got to bring it down again, x plus y, and since it's got to end up being negative, one of those is going to have to be a +3. Now I'm finished. Now this is just a strategy for you to use, mainly for that number 6 that's on your quiz. It's not exact, but this is some of the thought processes you have to do to try to break down what number 6 is. So that is your lesson for the day. I cannot remember if we prayed or not. So if we didn't pray, if you're practicing, I guess I should say, if you're practicing for your homework, I would suggest doing like 1 through 31 odd, just to get some practice in to make sure you know what you're doing. And then to go back, use for chapter 5 for that 10.5 quiz, go back, look over this table on 426 and go step by step. Look over some of the strategies we did. And let's go ahead and pray for your quiz and for everything else that's going on. So Heavenly Father, I just pray that you will give us clarity of mind as we try to finish up our quizzes and we try to finish up algebra. And Father, I pray that you'll grant, just help them with any problems they have. And Father, just be with our world. We are a hurt, dying, condemned world. And we pray that you'll just let your will be done on earth as it is in heaven, and give the wisdom of heaven to not only us, but to the authorities over us. We love you in Jesus' name. Amen. All right, guys, so if you have any questions, give me a text. Otherwise, try to use your strategies. And good luck. Tomorrow's lesson for May 1st is going to be reviewing for this test. So have a good day.